In this video, we're going to look at geometric sequences. So before we write down an official definition, let's look at some examples of geometric sequences. So let's take a look here. We've got 2, 8, 32, 128. What's the pattern here? Can you see what's happening? Yeah, hopefully you can see what we're doing is we're multiplying by 4. Each term is multiplied by 4 to get the next term. All right, let's look at the example B. Write that down. Times 4 times 4. Okay, so let's write out, let's see, the first term is 3 to the 1 plus 1, which is 2, so that gives me 9. All right, the second term is 3 to the 2 plus 1, which that gives me 27. The third term is 3 to the 4th, which gives me 81. And actually, if we look at the terms, even before we multiply them out, we can really see what's happening here. We're multiplying by a factor of 3 each time. All right, let's look at example C. Why don't you pause the video and write out the first 4 terms of example C. So hopefully you got 6, 12, 24, and 48. So what is happening here? Well, we're multiplying by 2 to get the next term. So this is the characteristic, the key characteristic of a geometric sequence is that to get the next term, you're going to multiply the previous term by something. So we call this the common ratio. So in this case, the common ratio is 4. In this case, the common ratio is 3, and in this case, the common ratio is 2. Now, those are all very nice numbers. The common ratio could be a negative, and the common ratio could also be a fraction. It could be a decimal. And we'll see some examples of that coming up. So the key definition of a geometric sequence, we would say, all right, let's say I have my first term of a geometric sequence is some number a. Then the nth term of the geometric sequence can be found by taking that common ratio and multiplying it by the term before that, which would be a sub n minus 1. I could also write this as a sub n plus 1 equals the common ratio times a sub n. Doesn't matter. All that this is signifying is that this is a term and this is the term right after it. This is a term and this is the term right after it. The subscripts tell us that either way that we write it. All right, so if I want to find the nth term of a geometric sequence, well, let's take a look and let's think about how this would all progress. So let's say I have my first term, a sub 1, and I'm just going to call that first term a. All right, so I know my second term is going to be a times r. Let's write it out over here too. I kind of like doing this, and then we'll write it over there as well. So my first term is a, so remember the characteristic is we're going to multiply by the common ratio. Multiply by the common ratio to get the next term. Multiply by the common ratio. Multiply by the common ratio. All right, so this is my a sub 1 term, so my next term is a sub r. Okay, or sorry, a times r. So now I'm going to take ar and I'm going to times that by r again. So what am I going to get? I'm going to get ar to the second. Then I'm going to times that by r again. So I'm going to get ar to the third. And I'm going to times by r again. I'm going to get ar to the fourth. All right, so this is my first term. This is my second term. This is my third term. This is my fourth term. This is my fifth term. How could we write out the nth term? ... What would the nth term look like? A sub n. Well, we would definitely be starting with a, and then we would be multiplying that by r to what power? Do you see it? The power is 1 less than the term number. The power is 1 less than the term you're on. So if I want the nth term, I'm going to multiply by r to the n minus 1. So that's my formula. My general formula is going to be the nth term is the first term times r to the n minus 1. So the two things that we need to know in order to write a formula are the first term and the common ratio. So let's take a look at this example here. We have the sequence 3, 2, 4/3, 8/9. Is that geometric? Well, we have to figure out if we're multiplying by something. And this can be a little tricky when it's not super obvious. Is there something I could multiply 3 by to get 2? Well, yeah, there is. It's, what is it? All right, what is that common ratio? You could actually just write a little formula and be like, well, 3 times what is 2? Divide both sides by 3 and it's 2/3. All right, let's try it. Let's see if it works. If I take 2 times 2/3, do I get 4/3? Let's see, is 2 times 2/3? Yep, that would be 4/3. All right, what if I take 4/3 times 2/3? Does that work? 4/3 times 2/3 would be 8/9. That works. All right, so my common ratio is 2/3. Now what's my first term? Well, that's easy enough. It's 3. So I'm just going to plug my common ratio in there and my first term in there. And I can write a formula for the nth term, which is 3 times the quantity. I want to put that in parentheses, 2/3 to the n minus 1. Well, now if I want to find any term of my sequence, it's pretty easy. If I want to find the 9th term of my sequence, a sub 9 would be to start at 3 and then multiply 3 by 2/3 over and over again 8 times. 9 minus 1 is 8. I think I'd probably use a calculator to help me with this one. Remember, when you're multiplying fractions, you can just multiply the top, right? So I'll have 2 to the 8th power over 3 to the 8th power. And then I could certainly cancel a factor of 3, which would leave me 2 to the 8th over 3 to the 7th. Let's plug that in and see what we get. Let's see, we get 256 over 2,187. I would leave it as a fraction. I'm pretty sure this is not a nice decimal. I mean, you could certainly find the decimal for it, but okay, a recursive formula. So remember, a recursive formula is going to have two parts to it. It's going to tell you what the first term is. So our first term is 3. And then it's going to tell you how to find the next term. So if I want to find the nth term, I'm going to take my common ratio, which is 2/3, and multiply that by the term before it, which is a sub n minus 1. So this is the recursive formula. All right, well, we can do the same thing we did with other sequences. We can find the sum of a geometric sequence. We could add up all the terms of this sequence up to a certain point, and that's called a series. Remember, that's called a series. So let's say we have the series, which is going to be the sum, right, of, so my first term plus my next term plus the term after that plus the term after that, all the way up to a times r to the n minus 1. So that would give me the sum of the first n terms. That's the first n terms, right? Because this would go to n minus 1. All right, well, how am I supposed to figure that out? That looks a little tricky. Okay, so this is kind of a slick little formula here. Here's what we're going to do. We're going to derive a formula for this. And remember, kids, that's right, don't drink and derive. So what we're going to do is we're going to multiply both sides of this by r. And you'll see in a minute why we're going to do that. And then I'm going to write that underneath here. Okay, so I'm going to get r times s sub n. And then I'm going to take r, all right, r times a. So that's going to be a r. And then r times ar. So that's going to give me ar squared. And then ar to the third, ar to the fourth, dot, 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 a. Now what's r to the n minus 1 times r to the first? Right, you're going to add those exponents together. So that's just going to give you r to the n. Okay, now I'm going to erase this part here. All right, maybe we'll just make a little note to ourselves of what we did. To get this, we multiplied by r on both sides. So now what we're going to do is we're actually going to subtract these from each other. So this is a little bit of a trick here, but it's going to be cool and you're going to like it. All right, so here's what we're going to do. We're going to take the green equation and we're going to subtract it from the purple equation. So what do we end up with on the left-hand side? Well, we have s sub n minus r times s sub n. Okay, now let's look at the right-hand side. Now, if I were to write all this out, right, I would have all this stuff minus all this stuff. Now, notice we have some like terms in here. I've got an a sub r, and then I would minus this a sub r. So those are going to end up going away. All right, and here I have a r squared minus this ar squared. That's going to go away. And you see what's going to happen here, right? This ar cubed is going to go away with this ar cubed. They're going to be 0. And all these are going to continue to subtract to be 0 up until the end. This very last one is going to subtract with this term right before it, which isn't written, to make 0. So all that's going to go away. And what are we going to have left? Well, we're going to have this a right here. And then we're going to have this a times r to the n. Now notice this is being subtracted, so it's going to be minus a r sub n. Pretty cool. All right, we really simplified that. Okay, now let's take a factor of s sub n out, and that's going to leave 1 minus r. And let's take a factor of a out here, and we're going to get 1 minus r to the n. You don't have to take the a out on this side, but I definitely want to take the s sub n out on the left-hand side because I'm solving for s sub n. I want a formula for s sub n. So now I'm going to divide both sides by 1 minus r, and I get a formula that says the sum of the first n terms of a geometric sequence is the first term times 1 minus the common ratio taken to the power of however many terms you're adding up, divided by 1 minus the common ratio. Now, if you're having any urges to cancel in this r or this 1 minus r, just kind of resist that urge, all right? You can't do that because this is r to the n. And that's it. That's the formula. Pretty slick. Now, before we go on and look at a more complicated example, let's just look at a really easy example so we can see how this works. So let's say I have a geometric sequence that starts at 1, and then I'm going to multiply by 2. I got to pick something to multiply by. Multiply by 2, multiply by 2, multiply by 2. All right, so let's say I want to find the sum of the first 5 terms. That's easy enough to do by hand, so we can use the formula and see how it's going to come out the same. Let's see, 8 and 2 is 10, and then 4 and 6 is 20, so that's 30 and 1. All right, so now let's use the formula and see how we get 31 and be amazed. So the sum of the first 5 terms is the first term, which is 1 times 1 minus the common ratio, which is 2, to the nth power, which is how many terms we're adding up here, which is 5, over 1 minus the common ratio. All right, what do we get here? Well, we get, in the parentheses, we get 1 minus 32. 2 to the 5th power is 32. So that's negative 31 over negative 1, which is, ta-da, 31, which is the same thing we got here, 31. So, yeah, I probably wouldn't use this formula if I was adding up the first 5 terms, but what if I wanted to add up the first 100 terms? It would be so easy, especially with a calculator, right? I just take my first term and my common ratio to the 100th power. Pretty slick. I love that formula. All right, pause the video and do this example using our cool little new formula here. Find the sum of the first 20 terms of the sequence 3 to the n. Wow, that's a big number. I guess that's what I would expect, though. I mean, look how this sequence starts. 3, 9, 27, 81. We're only 4 terms in, and we're going to keep multiplying by 3. So my common ratio is 3. So we put a 3 here in my formula and here in my formula. Well, it also turns out that the first term is 3. So I put a 3 there, and I work it all out, and I get a big old number. What is this number? Let's see. That's million, billion, 5,230,176,600. That's a lot of whatever it is.